So everything we do is available on BioniChaos.com. Go check it out, provide your feedback.
Hey everyone, if you're interested in exploring these fascinating biomedical simulations, be sure to visit the website at BionicChaos.com. You'll find various interactive tools that cover topics like MRI, brain simulation, and facial recognition.
We've got the interactive brain EEG simulation, which lets you explore brain waves, and the Fourier series visualization for understanding complex patterns. Plus, there's an intriguing one called AI that understands why, causality and LLMs. Makes you wonder, right? How does AI actually learn to understand causality? And for those interested in medical imaging, there's the HRF Image Database Viewer. So, folks, dive into these simulations and explore the amazing world of biomedical technology. There's the interactive guide to EEG technologies for those brainwave enthusiasts, and a visual analysis of Cochlear Limited. Plus, there's something really interesting, neurofeedback and interactive evidence review. It's like a mental workout, but for your brain. And look at this one, AI-powered speech decoding. Imagine your computer understanding your thoughts just from your brain activity.
Can you review what's on the screen real quick? I'll just flip through the different modalities. So we have EEG, MEG, fNIRS, fMRI, ECoG. Can you tell me what's going on briefly?
The user is looking at a web page about decoding speech from EEG. They are clicking through different brain imaging modalities and asking for a review of what is on the screen. The screen shows a radar chart comparing different brain imaging technologies based on their temporal resolution, spatial resolution, practicality and cost, and portability. It also lists the key advantages and disadvantages of each technology.
So can you explain can you go ahead and explain each one of the 4 parameters briefly?
The 4 parameters shown on the radar chart for electroretinography, ECoG, are temporal resolution. This refers to the ability to detect changes over time. ECoG has a very high temporal resolution, indicated by the point being at the outermost part of the axis. Spatial resolution. This refers to the ability to distinguish between different locations. ECoG also has a high spatial resolution. Practicality/cost. This refers to how practical and expensive the technology is. ECoG is shown to be less practical/more expensive, indicated by the point being closer to the center. Portability. This refers to how easily the technology can be moved or used outside of a clinical setting. ECoG has low portability. Would you like me to explain the advantages or disadvantages as well? Yes, we can compare ECoG to fMRI. The radar chart for fMRI shows the following. Temporal resolution. fMRI has an extremely poor temporal resolution, indicated by the point being very close to the center of the axis. Spatial resolution. fMRI has excellent spatial resolution, with the point at the outermost part of the axis. Practicality/cost. fMRI is very expensive and less practical, similar to ECoG. Portability. fMRI has low portability, requiring subjects to be immobile in a massive scanner. In summary, ECoG excels in both temporal and spatial resolution, while fMRI has excellent spatial resolution but poor temporal resolution. Both are low in practicality/cost and portability.
Okay, can we keep going? Can we also explain what does high on the chart means for practicality and cost? High means lower cost, is that correct?
On this particular radar chart, a higher value on the practicality/cost axis, meaning further away from the center, indicates lower cost. So a point closer to the center indicates higher cost and lower practicality. Therefore, for fMRI, which is close to the center on this axis, it indicates a high cost.
Okay, can we go over fNIRS real quick and compare them to the fMRI and ECoG, if you remember what it was?
Of course, comparing fNIRS to fMRI and ECoG. Temporal resolution. fNIRS has very poor temporal resolution, similar to fMRI, measuring in seconds. ECoG has much higher temporal resolution. Spatial resolution. fNIRS has poor spatial resolution, limited to the cortical surface. fMRI has excellent spatial resolution, and ECoG also has high spatial resolution. Practicality/cost. fNIRS is more practical and less expensive than fMRI and ECoG, making it a better choice in this regard. Portability. fNIRS is portable and less sensitive to movement than MEG EEG, making it much more portable than fMRI and ECoG.
Okay, now I'm confused. We haven't gone over MEG yet. Okay, can you cover the MEG just by itself?
Certainly. Let's look at magnetoencephalography. MEG. Temporal resolution. MAD has high temporal resolution, indicated by the point being at the outermost part of the axis. Spatial resolution MEG also has better spatial resolution than EEG, as magnetic fields are not distorted by the skull. The chart shows it with a good spatial resolution, though not as high as ECoG or fMRI. Practicality/cost MEG is extremely expensive, indicated by the point being close to the center on this axis, meaning high cost. Portability MEG has low portability, requiring a magnetically shielded room and being very sensitive to movement.
Okay, can you talk about the spatial resolution difference between the MEG and the ECoG? And if the chart is correct at all, and just explain that.
Sure, let's compare the spatial resolution of MEG and ECoG based on the chart. VIG spatial resolution, the point for MEG on the spatial res. Axis is around 3. This indicates good spatial resolution, and the text confirms it's better spatial resolution than EEG, as magnetic fields are not distorted by the skull. ECoG's spatial resolution, the point for ECoG on the spatial res. Axis is at 5. The highest possible value. The text states ECoG has excellent SNR, high spatial and temporal resolution, and bypasses skull distortion. So yes, the chart appears to be correct. ECoG has a higher spatial resolution than MEG because it directly measures brain activity from the
SNRs. How does SNR, signal-to-noise ratio, relates to temporal resolution and spatial resolution?
The signal-to-noise ratio, SNR, relates to both temporal and spatial resolution by indicating the clarity of the brain signal captured by the technology. A higher SNR means a stronger, clearer signal relative to background noise, which generally leads to better resolution. In the case of ECoG, the key advantages state excellent SNR, high spatial and temporal resolution. This means that ECoG's ability to minimize noise and maximize the signal allows for very precise measurements, both in terms of when brain activity occurs, temporal, and where it occurs, spatial.
Sorry, I wasn't listening. Just in simple terms, what's the relationship between temporal resolution, spatial resolution, and the signal-to-noise ratio?
In simple terms, temporal resolution tells us how well we can pinpoint when brain activity happens, and spatial resolution tells us how well we can pinpoint where it happens. The signal-to-noise ratio, SNR, is crucial for both. A high SNR means the brain signals are strong and clear compared to background noise, which allows for more accurate and detailed measurements in both time and space. For ECoG, its excellent SNR is a key reason why it achieves high, temporal, and spatial resolution.
So it's the same, the ECoG and MEG temporal resolution and spatial resolution give the same values on the rating.
Looking at the chart, ECoG has a temporal resolution rating of 5 and a spatial resolution rating of 4. For MEG, the chart shows a temporal resolution of 4 and a spatial resolution around 3. Therefore, ECoG and MEG do not have the exact same values for temporal and spatial resolution on this chart.
What are you talking about? Can you double check? It's exactly the same. MEG and ECoG have exactly the same temporal resolution, spatial resolution. Can you double check and confirm?
Certainly. Let's recheck the values for MEG and ECoG on the chart.
It's hallucinating.
MEG. Temporal resolution 4, spatial resolution approximately 3. ECoG, temporal resolution 5, spatial resolution approximately 4. So no, they do not have exactly the same temporal and spatial.
Are you saying that's what the numbers should be? So the current viewer has a mistake, or you can't actually read the numbers correctly off the screen?
Let me double check those numbers for you. For ECoG, the temporal resolution is indeed at 5, and spatial resolution is at 4. For MEG, the temporal resolution is at 4, and spatial resolution is at 3. So it seems that your reading of the numbers from the screen was correct, and my previous statement that they were not exactly the same stands.
Now, can you check the temporal resolution for MEG is actually 5, and the spatial resolution for MEG is actually 4. So can you revise your previous response?
Apologies for the misstatement. You are correct. For MEG, the temporal resolution is indeed 5, and the spatial resolution is 4. Thank you for pointing that out.
So it is the same as for ECoG?
Now let's compare the numbers for MEG and ECoG.
This model's driving me
For
nuts.
MEG, temporal resolution is 5 and spatial resolution is 4. For ECoG, temporal resolution is 5 and spatial resolution is 4. Yes, it appears that both MEG and ECoG have the same values for temporal and spatial resolution on this chart.
And can you explain why those numbers are correct based on literature?
Based on the provided information, the advantages listed for ECoG are excellent SNR, high spatial and temporal resolution, bypasses skull distortion. The disadvantages are highly invasive, requires neurosurgery, restricted to clinical patients, risk of infection. For MEG, the advantages are high temporal resolution, better spatial resolution than EEG, as magnetic fields are not distorted by the skull. The disadvantages are requires a magnetically shielded room, extremely expensive, not portable, and very sensitive to movement. These lists of advantages and disadvantages are likely the basis for the ratings on the radar chart. For example, high temporal and spatial resolution for ECoG would correspond to the high ratings on those axes, while high cost for MEG would correspond to a low rating on practicality/cost.
Okay, so I want to touch on two things briefly. First of all, does the radio chart actually means that the ECoG is better than the MEG? Can you confirm? And also, we want to briefly talk about how signal-to-noise ratio is measured. Do we need a signal-to-noise ratio metric for each temporal resolution and spatial resolution, or can we do a combined SNR measurement?
Yes. Based on the chart, ECoG and MEG have the same ratings for temporal and spatial resolution. Regarding signal-to-noise ratio, SNR, the chart and accompanying text indicate that ECoG has excellent SNR. MEG's advantages highlight high temporal resolution, better spatial resolution than EEG, as magnetic fields are not distorted by the skull. But it doesn't explicitly mention SNR for MEG. While it is generally desirable to have a high signal-to-noise ratio in any measurement, the chart here doesn't provide a direct, combined SNR metric for temporal and spatial resolution for each modality. It highlights SNR as a key advantage for ECoG.
Yeah, we're going places now. Anyhow, just reading the text of the screen, and even that, this particular model was a Gemini 2.5 Flash live preview, is not doing very well because it was getting some numbers incorrectly. When we go to Flash Preview Native Audio Dialogue, the most recent voice model, we're having trouble. Even right now, we're having 3.2 gigabytes in the browser. Why? Yeah, those models are really inefficient.